Factoring trinomials from lesson 5-6 in our book. It's the second part of the lesson. We're also going to be continuing to take a trinomial like the one here, 6x squared minus 23x plus 20, and we are going to factor to get an answer of a binomial times a binomial. When I teach this, I like to teach it from what you're already familiar with and how to multiply these to get to this answer. But our goal by the end of the lesson is to be able to start here and work our way back here. So we're going to start with the trinomial and end with a binomial times a binomial. Now, when we do this with this type of a problem, I want to go back to when you multiplied a binomial times a binomial. Notice down here in the trinomial, this first number is a 6x squared. Everything you did in the first half of this lesson had just a plain x squared. If I look at this, I have a 6, a 23, and a 20. There are no common factors to pull out of there to create a plain x squared. So now what do we do when we're given a trinomial that I can't factor the numbers out, I can't get a plain x squared? There are patterns there. I'm going to show you these patterns. Let's go back to when we had a binomial times a binomial. So to do this, you would have taken 2x and you would have multiplied it times 3x. Now notice those are the first terms in both binomials, and in our work here in the middle, it is the first term here, because 2x times 3x is 6x squared. Another thing that you did is you would multiply the negative 5 times the negative 4. These are the last terms in the binomial. That also creates the last term in my work here and in my trinomial. So the question now becomes, I have found my first term and I found the last term. How do I figure out the middle term? Where does that come from? Okay, where does that middle term come from? Well, here's where it comes from. It comes from the other factors being multiplied. So let's take a look at that. I have, well, to find these middle, where does this negative 8x come from? Negative 8x comes from the 2x times the negative 4. So a first and a last. So that's where that comes from. That's right here. The next question then is, where does the minus 15x come from? It comes from doing the last and the first. So here. So this pair is created here, and this pair goes here. So what we have to take a look at is we used multiplication factors. We did a factor of 2 and a factor of 4 to get 8. We had a factor of 5 and a factor of 3 to get 15. When I add these two together, I get the minus 23 here in the middle. So now how do we factor all of that? That's what we've got to figure out. How do we factor all of that? So to take a look at that, let's see where it comes from. Two factors, if I have factors of 2 times 4 and a factor of 5 times 3. And yes, there were negatives here and here. So I have a factor of 8. I have a negative 8 that came out, and I have a negative 15. Now those added to negative 23. So the question to look at is, do these two numbers, negative 15 and negative 8, have a relationship with the 6 and the 20? Because that's where those factors came from. They came from the outside where the 6 is, and they came from the last where the 20 is. Is there a way to use, when I look at this, is there a way to use negative 8 and negative 15 that are related to 6 and 20? Addition won't work. 6 plus 20 is 26. Negative 8 plus negative 15 we know to be negative 23. So here's what's then done. What we do is we say, what is negative 8 times negative 15? Negative 8 times negative 15, negative times negative, positive. It gives me a sum of 120, or a product of 120. How do 6 and 20 relate to that? Correct. 6 times 20 is 120. So when we are trying to factor a trinomial, we want to do the factors of the outside two together. So I would multiply them. I would say I want the factors of 120 so to find the middle term, factors of 120 with a sum of negative 23. This is what we're looking for. So I'm going to go through some examples and I'll show you how that works. And it'll also include some of the factoring by grouping that you were doing from lesson 5.5. So looking here at this trinomial, 3x squared plus 13x plus 4. All right, something was added together to get 13x. So what I have to figure out is, where did those factors come from? They came from our outside terms, our first term and our last term. So what I have then is I have the factors of positive 12, sum of 13. Now some of you looking at that say, oh, I know what that is already. You may, which would be great if you do. So here's how we do it. We aren't going to necessarily put parenthesis like we did when we had a plain x squared. We can't do that. We have to break this apart into what did it look like before that middle term was added. So to do that right away, I will write down my first term. My first term right away I know is 3x squared. So I got to figure this out. I know I'm going to have a 3x squared here. And I know I'm going to have a term here and a term here, followed by a plus 4. But what I have to figure out is, what are those terms that are going to be here? So I go to my t-table, factors of positive 12, sum of 13. And I will just start. If it's a positive 12 and a positive sum, I want all positive factors. And I can start right away with 1 and 12. And I'm fortunate on this one because I know that 1 plus 12 is 13. If it wasn't 13, I would keep going. I would then do 2 and 6, which is 8, 3 and 4, which is 7, and then that would be it. So now when I look at this, 13 is the only one that I need. So I wouldn't necessarily have to do the 2, 6, 3, 4 because I already found what I was looking for right here. This is what I'm looking for. So how do I put that over here in my problem? So then I say, okay, I have a factor of plus 1x, or I can write just x, and another factor of plus 12x. That's what this middle term looked like before the two terms were combined to make 13x. Now that I have that, I want to get this so I can write parenthesis, parenthesis. The way to do that is I would use my factoring by grouping. I will look at the first two terms. So I'm going to look here, the 3x squared and the plus x. I'm going to look at that. Is there a common factor between those two? Yes, x is the common factor. Parenthesis. 3x squared divided by x leaves 3x. X divided by x leaves a positive 1. And I'm done with the first two terms with their grouping. Let's now group the last two terms, and let's see if there's a common factor there. There is. There is a common factor of 4. Now, as I work through this, I've got a common factor of 4. Put my parenthesis. I want to create another factor over here of 3x plus 1. If I don't get that, then I'm done factoring that original trinomial. If I take 12x now and divide by 4, I get 3x. That's a good thing because I have 3x over here in the other set of parentheses. 4 divided by 4 plus 1. So now, have I created a common factor inside the parentheses? Yes, I have. That means I will now write that if I knew what x plus 4 was, I would add those together. X plus 4 times 3x plus 1. And now I have factored the trinomial. So I've now gone the other direction. Just to double check it if you'd like to, x times 3x, 3x squared. X times 1 is x. It's right there. 4 times 3x, 12x. 4 times 1, 4. All right. So this is the type of pattern to use for this. Now this had all pluses in it. If you feel at any point that you have this understood in the video, it's okay to pause the video and forward it to the last page. I would appreciate if you choose to skip one of these next two problems on this page. Be sure that you watch the very last example before you write down the assignments. Here's another example for you. I have 14x squared minus x minus 3. I need to use factors of what? Factors of negative 42. Where did I come up with that? I multiply 14 times the negative 3. That gives me the factors of negative 40. What sum do I need? What I have to look at is what sum do I need in this problem? I need a sum of, what's my number on the middle term? I need a sum of negative 1. Sum of negative 1. Factors of negative 42, sum of negative 1. Remembering our pattern from when we looked at things before, I have factors of negative 42. If I have a negative here, that means one of these numbers being multiplied has to be negative. If I want a sum of negative 1, that means the factor further from 0 needs to be the negative number because I want a negative sum. All right, looking at 42. Now, for demonstrations reasons, I know some of you have already got it in your head that you know what those two factors are. Let me just go through an example. So if I have it this way, factors of negative 42, okay? If I'm not sure what they are, then I'm going to just start with 1 and negative 42. The sum of that is negative 41. Now that's in the correct method. That means my smaller number should be the number not as far from 0 should be positive. The number further from 0 should be negative because I got a negative answer and I'm looking for a negative sum. So I can go 2 and negative 21. That is negative 19. Okay, it means I'm going the right direction with this because I'm getting closer to negative 1. The next pair of factors are 3 and negative 14. This is negative 11. 4 is not a factor of it. 5 is not a factor, but 6 is. 6 and negative 7. Now, I think many of you probably thought right away that's what that was, and that is correct. So now that I've found the two factors that I need, the 6 and negative 7, that gave me the sum of negative 1. So that's the pair I'm after right here. I'm going to go over here and start my work. I know to start with that the first term is 14x squared. I'm going to have two terms in the middle, and I'm going to have a minus 3 at the end. And in the middle, I will be putting a plus 6x and a minus 7x. Question comes to mind sometimes, could I put these two in a different order? Could I put the 7x, the minus 7x on the first blank, the plus 6x on the second blank? Yes, you can. You can certainly do that. And some of you may find reasons to do that later. Okay, looking here now, I'm going to do the factoring by grouping because I need to create a binomial times a binomial, and factoring by grouping creates that very easily for us. So we have I have 14x squared plus 6x are the first two terms. The common factor there in the numbers, the common factor is 2. The common factor with the variables is x, so I will write 2x, and I put my parenthesis. Now, excuse me, I have 14x squared divided by 2x, that is 7x. 6x divided by 2x plus 3. Let's take a look at the next two terms. I have minus 7x minus 3. Now, notice there are no number factors that are common. There are no x factors. But there actually is a number factor in common here. Take a look at what we created in parentheses here. We created a positive 7x plus 3. Here it's negative 7x minus 3. So to create positives here, I will pull out a factor of negative 1. And then I will say negative 7x divided by negative 1 is 7x. Negative 3 divided by negative 1 plus 3. And now I have a common factor between the two terms, which allows me to add the two numbers in front together. So I can say, all right, this is 2x, and I'll write minus 1 times 7x plus 3. And that's all it is. Then we're done. We have binomial times binomial. If I was to remultiply, it's 2x times 7x, 14x squared. 2x times 3, 6x. Here's a negative 1 times 7 is minus 7x. So I get a negative 1x when you put those together. And the last term is negative 3. So I've done it correctly. Moving on to a third example here. 4x squared plus 6x plus 9. Okay, so if I look at that now, I know this middle term is created from all the factors of 9 and all the factors of 4. So we will take a look and let's type in, we have to have the factors of 36 that have a sum of 6. All right, so we're set on this. Let's start working with our factors. Factors of 36, positive sum. So 1 and 36, sum of 37. 2 and 18, sum of 20. 3 and 12, sum of 15. Going down, so I'm going the right way. 4 and 9, that's 13. 6 times 6, that's 12. Are there any more? 1, 2, 3, 4, 5, 6. Let's see, 7. No, 8. No, back to 9. And I already have 9. I don't get a sum of 6 on this one. What does that mean when I have used all the possible factors of positive 36 that will give me a positive sum? It means this. It means this problem, while eventually may be solvable, you cannot factor it. So we write this word. We call it prime. P-R-I-M-E, prime, which means there just are no integer factors just used to solve for this. So we call it prime. So if you get down going on a list of factors and you exhaust all the factors there, none of the sums work, then it's prime. You make sure that when you do a problem and you say prime for the answer, this is the evidence that supports your answer. If you don't have that t-table to support prime, that's poor quality work. For good quality work, we show this t-table here, and that supports my answer of prime. All right, one last example here. I know this video is getting long. We have 5x to the fourth plus 29x squared minus 42. The reason for this example is the fact that I have a x to the fourth here, but notice my middle term is x squared. So what do we need? We still follow the same procedure even though I have x to the fourth. This is a square out here. So I need the factors of, and I have to then do 5 times negative 42, and I did that before I started the video, and I know that answer to be negative 210. I need a sum of positive 29. Sum of positive 29. So let's get started with that. If I start then, I need a positive answer. This is negative. That means one of the factors has to be negative, one positive. Since it's a positive sum that I'm after, I want the number further from 0 to be positive. So that means this. It's negative 1 times 210. That's 219. Divide negative 2, 210. Divided by negative 2, that's going to be 105. So those two, when you add them together, is 103. Starting to get closer. Negative 210 is divisible by negative 3. And how do I know that? To find out if a number is divisible by 3, add up the separate digits. 2 plus 1 plus 0 is 3. If the answer to that addition is divisible by 3, the big number is divisible by 3. And this happens to be 70. Okay. Next then, when I add those together, I get 67. I want to check, is that divisible by 4? Let's see, 21, 4, 50. Nope, that one's not divisible by 4. I do know it's divisible by 5. So negative 5. How many do I get out of that? 21 divided by 5 is going to give me a 4 here. And then I have one extra, so it's going to be 2, negative 5 and 42. When I add those together, I get 37. Getting closer. I bet the next pair I find. Let's see, does 6 work? Can I use a 6 in here? Let me grab the calculator quick. I believe it does work. And it does. Okay, so it's negative 6, comma, and it's 35. And when you add those two together, I get a sum of 29. So there's my middle term, my sum here, right here. This is the one I'm after. I can stop here. I don't need to go any further. So when I write over here now, I have 5x to the fourth. I got to have a middle term here, a middle term here, and a minus 42. So now as I write the middle terms, notice up here it says x squared. So I have plus 29x squared. I will write minus 6x squared. And then I will put plus 35x squared. And how is that determined? Well, let's do the factoring by grouping and you'll see how that worked. So when I look now in the first two terms, the numbers don't have a common factor other than 1. However, x to the fourth and x squared, they do have a common factor of x squared. So I will write x squared, parenthesis, 5x to the fourth divided by x squared, 5x squared. Negative 6x squared divided by x squared, minus 6. Now I look at the factoring by grouping for the last two terms. The common factor there, 7. And I'll put parenthesis, 35 divided by 7, that is 5. Oops, x snuck in there on me. So that is 5. The x squared stays there. And again, I am trying to create the same factor here as it is in the parentheses there, which is going to happen. Negative 42 divided by 7, minus 6. Now, I will put my two binomials together. Since I have a common factor, that means I can add the first terms on the outside. I'm going to go parentheses, x squared plus 7 times 5x squared minus 6. All right, lots of detail there. Give it a shot. Now down here I have two different assignments for you. And the reason there's two, this one right here, the first one, page 304, that is all work on all the examples I just did in this video. Then this assignment, the second one, that is an assignment that puts all of the 5, 6 together. So everything that has a plain x squared at the start to anything where you have to do what I did in this video here. I would pause the video here or stop it here and make sure then that you copy down these two assignments. These are two separate assignments, so turn them in separately as soon as you finish them. Thanks for watching.